All right, so welcome to the next lesson, the third lesson in stats and probability. So we're starting out with stats. So the first thing that we need to realize is we're going to be talking today about sampling, and we spoke last time a lot about like outliers. We're going to touch on that again a little bit today. We do want to do a couple of definitions first. So there's different types of data. So one example is called discrete data, which is like exact numbers. We use this like to count, right? So this is the number of students in the class. You could say like number of favorite colors in the class, number of whatever grapes that you're eating. So it's exact numbers. These are whole numbers. Okay, they're not decimals. Um, Continuous data, though, can be a decimal, is any value in a range. When we do presentation of data, we use a bar graph for discrete data. So definitely make a note of that, right? And again, discrete is numbers that are whole numbers, okay? And for continuous data, we're going to use a histogram, okay? So you could have like an interval, and then that we can have like the age can be 3.5 years old or whatever, right? So that's for continuous data. Um, and we'll talk a little bit more about the differences between a bar versus a histogram. Histogram, the bars will touch, and a bar graph, it does not. So population, right? For SL, we're going to assume, you can make an assumption, that any of your data sets are going to be representative of the entire population. So we're always going to use population standard deviation and the mean for the whole population, okay? This is not true in real life. However, for SL, which is what we are, we're going to use data sets are representative of the whole population, so which is why we're going to use the population standard deviation and the mean for the population. All right. A sample is like if I have all the people in Roosevelt campus, a sample might be kappa, right? A sample is like a smaller part of the population. Um, and you can end up making false conclusions or interpretation of the whole data based off of just doing a sample. So we're going to talk a little bit about the different ways that you can do sampling. Data that is reliable should be repeatable. Like if you're doing an experiment and you're figuring out like plant growth and there's a controlled an experiment, you should be able to repeat your experiment or whatever it is that you're doing. And if you have missing data, that can definitely affect your reliability, right? Like, so how you collect the data, making sure that you're getting good data samples, that also can make sure that data is reliable. And you also want to make sure that you do not have bias, right? So favoring one outcome over another. So if you're polling people and you notice that you are only sampling males and not females, then that is biased, okay? Because you need to get a representative of the population. So we try to minimize bias. This is very similar to Algebra 2 by increasing the randomness, okay? So more random it is, the less bias there is. The less bias there is, the more random it is, okay? All right, so there are 5 different types of sampling. For AISL, there is a lot of convenience sampling. There is a lot of random sampling. So we'll talk a little bit about what each of these mean. So simple random is literally just like, for example, giving everybody in the school a number and picking a number randomly by using a number generator or choosing numbers out of a hat. So that is an example of simple random, okay? So it's an equal chance of choosing each person, and everybody gets a number. You're picking one person or choosing out of a hat, number generator, whether it's digital or physical, okay? Convenience is literally just like asking people who are convenient, right? Like, so if you're doing a survey and you just ask your friends, that is based off of convenience sampling, right? But the problem with that is it might not be representative of the whole population. They might be biased. And so we want to make sure that convenience, we have to remember that that is not always representative of the whole thing. All right. Systematic is like, for example, you're choosing a random number. So if I say like I'm going to pick the first person, and then you're picking a random starting point, and then you're using a fixed interval after that. So for example, you're choosing every third student, so the student numbers are going to be like 1, 4, 7, so on and so forth. That is something called a systematic. Okay, you're being systematic about how you are sampling. Quota sampling, right? If the whole population has 55% girls and 45% boys, then your sample should have the same percentage, right? Or the same sample, the sizes in proportion. So if you have the whole population, and again, there's 55% girls and 45% boys, then you want to make sure that this is our 55 and this is our 45. You want to make sure that your sample also has the same proportion, okay? And that is sample standard, that is quota standard deviation or quota sampling, okay? Stratified is like you are taking your whole population, uh, right, whatever it is, and then you are putting them into smaller groups. So you're saying, okay, this is DP1, this is DP2, and we're going to pick half of the people in DP1 and half of the people in DP2, and we're going to do a stratified sampling. Okay, so those are the different types of sampling techniques. You do need to know all five, but like I said, the ones that are popular, especially for AISL, are definitely convenience sampling. I have seen random sampling as well as systematic. They don't usually do quota stratified, but you do need to know what that is. Okay. All right. So this is just going through a couple of more scenarios, and now we're going to be talking about outliers. All right, so we've been talking about this a little bit from the last couple of lessons, but outlier, there is a formula which is not on the formula booklet, but it is more than 1.5 times the nearest IQR, the nearest quartile. So there is a formula. So for the lower, the formula is going to be Q1 minus 1.5 times IQR. And for your upper outlier, the formula is Q3, because that is the one that's on the upper, plus 1.5 times IQR. Okay. And these formulas, unfortunately, are not in your formula booklet, so you have to memorize them. Okay. All right. So outlier, just by for a picture, right? Remember that. Let me just change the color so you can see it a little bit better. So this is our min, this is our max, this is our Q1, this is our Q3, and this is our median, aka Q2. And an outlier falls, right, like above those or below, okay? So if you have, and there's a mathematical definition for what this is, so you need to know these formulas. All right, so how do we find that? We want to show that 52 is an outlier, and you're not always going to throw out the outlier. You have to make a decision about that. So for example, if this is like heights and you have a person that is very, very, very tall, you have to decide if they are affecting the data and if you should remove that data from the data set. But we do want to play it depending on the situation. Okay, so I'm going to go ahead and pull up my. All right, so just to refresh your memory about what you do now, right? So you're going to go to stat, you're going to go to edit, you're going to put your numbers in, then you're going to go to stat again. You're going to go over to calc. Option number 1 is one var stats. We don't have a frequency list, so we can leave that blank and just hit enter. And so we're going to write down the things that we absolutely need, right? So for our formula, we need our Q3 and our Q1. We don't care about the median. We don't care about the min or the max, okay? So our Q1 is 13, so we're going to write that down. Q1 is equal to, what am I writing? Is equal to 13, and Q3 is equal to 19.5. Okay, so looking at the data set, I can see that, we have a very low number here, which is 3, and we have a very high number here, which is 52. So why don't we find both, right? Like, is 3 an outlier? Is 52 an outlier? Okay. So our formula again is Q1 minus 1.5 times our IQR, and this is to find the lower outlier. So our Q1 is 13 minus 1.5 times our IQR is going to be 19.5 minus 13. And so then I go to my calculator and I literally just plug that in, right? So I'm going to do 13. Why am I doing 13, 16 then? 13 minus 1.5 times IQR, which is 19.5 minus 13. Okay, so close parentheses, hit enter. So I get 3.25. So this number is 3.25. Therefore, okay, so 3 is less than 3.25, so 3 is an outlier. Hmm? So that's what we just found out right now. Now we do the upper one, right? The higher one. So for that, it's Q3 plus 1.5 times IQR. So I'm going to go to my calculator right here, and I kind of, not cheating, but just try to save myself some time. So instead of 13, I'm going to put 19.5 here because that's my Q3. So I'm going to do 19 and insert my 0.5. So second delete. So 0.5. And then I'm going to change this from minus to a plus. It's still 19.5 minus 13. Okay. Ooh, what did I do? Go to. Yes, let's take this out. All right, good. So I have 29.25. So this number right here is going to be 19.5. Look at me showing work. Plus 1.5 times 19.5 minus 13. And this number is what we get again. We got 29.25. So 29.25. So therefore, 52 is also an outlier because 52 is greater than 29.25. All right. So why should we care before we do some sample problems? So this tells us how we can take some good samples and also when to remove our outliers. That's important to statistics, right? So if you have something that falls out of your data set, right? If it falls on either side, whether it's lower or upper, this is definitely some things to keep in mind for your IA, which you're going to be writing between now and the end of the year. So we're going to go ahead and do these questions that are here. Ask if you need help. All right. Good job.